So here is another review video for the similarities in right triangles. This time it is the standard 1.2. And so we are given the vertices of triangle JKL are J, -3, -2, K, 1, 4, and L, 4, 2. Find the coordinate pairs of the vertices of the dilations with the scale factor of 5. So for dilations, anytime we're given the coordinates or given a figure on a coordinate plane, we need to get the coordinates, and then to get the coordinates of the vertices after the transformation, or the prime points. Okay, so in order for us to go from J at -3, -2 to J prime, we're going to multiply by the scale factor each coordinate. Okay, so to go from J at -3, -2 to J prime with our scale factor of 5, we're going to multiply our X and our Y value times 5. So in other words, we go from XY to our scale factor times X, our scale factor times Y. Okay, so in this case, -3 times 5, we get -15. -2 times 5, we get -10. So K prime and L prime would both be at 1 times 5, 5. 4 times 5 gives us 20. 4 times 5 gives us 20. And 2 times 5 gives us 10. So our new prime points, J prime, K prime, and L prime, after a dilation with a scale factor of 5. Again, since our scale factor is greater than 1, we know our image should be getting bigger. So we just multiply the scale factor times the X and the Y coordinate to get our new prime points. Another example, similarities in right triangles and beyond. So in the diagram below, triangle ABC. So this first triangle is similar to triangle DEF if AB equals 6 and AC equals 8, which statement will justify the similarity by SAS, and that is side, angle, side. So we know when we're comparing two triangles to be similar or not, the angles need to be congruent and these sides need to be similar, or in other words, they need to be proportionate. So of these 4 answer choices, we can go ahead and rule out C and D, because we know angle C and angle F, if they're congruent, is not going to give us the similarity SAS. So our angle has to be the included angle between the sides that are proportionate. So in this case, angle A and angle D. So we need to find a length for DE that is proportionate with AB. That is also equal to AC and DF. So in other words, 6 and so 6 over, and we're just going to go through our first choice. So our first one, answer choice A, we've got 9 and 12. So if we divide 6 by 9, you get 0.67. And if you divide 8 by 12, you get the same thing. So those sides would be proportionate. And let's just check to see if B would work as well. 6 over 8, 8 over 10. If you divide 6 and 8, you get 0.75. If you divide 8 by 10, you get 0.8. So since those ratios are not equal to each other, we know that those would not be proportionate. So the only proportionate side and the correct angle included to give us these two triangles similar by SAS would be answer choice A.